Okay, I'm going to start you on pages 130 through 136 in Module 3. I'm going to work problems 1 through 5 with you and then turn you loose on 6 through the rest of it. And so, again, if you have questions, let me know, and I'll be posting the answers to those problems in the next video. Let's take a look at number 1. El Capitan is a 3,000-foot vertical rock formation in Yosemite National Park in California. The granite cliff is one of the most popular challenges for experienced rock climbers. On July 3, 2008, Hans Florin and Yuji Hariyama scaled El Capitan in a record time of 2 hours, 43 minutes, and 33 seconds. Again, El Capitan is just a sheer granite face. It's a pretty remarkable climb, but you can walk or take a hike up the backside of the mountain, and you don't have to scale a sheer face to get up to the top and look down. Every year, people go and test themselves on it. And so this problem is based on that incredible challenge. On average, how fast did they climb in feet per minute? Or on average, about how fast in feet per minute did the record holders climb? Well, their time was 2 hours, 43 minutes, and 33 seconds. They're asking us in feet per minute. Oh, and it was a 3,000-foot wall. So they went 3,000 feet in that amount of time. They're asking us feet per minute. So I need to turn all of these units into minutes. So my first move is going to be to turn hours, minutes are already in minutes, and turn seconds into minutes. Let's turn hours. Again, there's 60 minutes in an hour. 2 hours is going to be 120. But let's set it up mathematically. 2 hours, I'm just going to put it over 1. And we want to know how many minutes. Well, 2 hours, I'm going to multiply by a unit rate, by a fancy 1. Hours is in the numerator, so I'm going to put hours in the denominator. And the unit I'm after is minutes. So I'll put that in the numerator. How many minutes are in an hour? 60 minutes are in 1 hour. And this is where you get to use some math skills. Hours cancel out. 2 times 60, 120. 1 times 1 is 1. 120 over 1 is 120. And my units left behind is minutes because hours cross-canceled. Minutes, 43 minutes, those are already in minutes, so that's nice. Seconds. What portion of a minute is 33 seconds? I don't know that off the top of my head. That's not easy like this one. But I can, if in doubt, I can set it up the same way that I did this. I know there's 33 seconds, and I want to find out the number of minutes. Well, I'm going to put 33 seconds over 1. That doesn't change the value. Seconds are in the numerator, so I'm going to put seconds down here in the denominator, and the unit I'm after is minutes, so I'm going to put that in the numerator. There's 60 seconds in 1 minute. These cross-cancel, so I'm going to end up with 33 over 60. Well, what is 33 divided by 60? This is where a calculator comes in handy. It should be about 0.55, but let's double check. 33 divided by 60. It is 0.55. So 0.55 minutes. So I have 120 plus 43 plus 0.55. These climbers went, and this is in feet per minute, so I'm going to put feet on top, 3,000 feet in 163.55 minutes. Well, that doesn't make sense. I mean, it does, but that's not a really good speed. The speed is going to be a unit rate. How many feet per 1 minute are these guys traveling? So 3,000 feet. I need to turn 163.55 into a 1. I'm just going to divide both sides, top and bottom, by 163.55. Because any number divided by even a fancy one is still itself. So this number and this number are going to be the same. 163.55 divided by 163.55 is 1. 3,000 divided by 163.55 is a good time to use a calculator. 3,000 on my calculator divided by 163.55 is approximately 18.34. Approximately feet per minute. So these guys went up the mountain 18 feet vertical in 1 minute, and they averaged that rate for just under 3 hours, 2 hours, 43 minutes. That's a monster climb. 2 new climbers want to attempt to break the record by climbing El Capitan in 2 hours and 30 minutes. So they're trying to beat that record. They're trying to beat them by 13 minutes and 33 seconds. If these climbers are to reach their goal, on average, how fast in feet per minute will they have to climb? Well, we already know that 2 hours is 120 minutes. So these climbers are trying to go up the 3,000-foot face in 120 plus 30 in 150 minutes. Let's turn that into a unit rate. Let's find out how many feet per 1 minute. Well, I need to turn 150 into 1. So if I divide 150 by 150, I get 1. And if I divide this whole fraction by a fancy 1, 150 divided by 150, well, is a fancy 1. 3,000 divided by 150 should be 20, but let's verify on a calculator. 3,000 divided by 150 is 20. So they want to average 20 feet every minute. Sometimes, some of the climbing obviously is going to go faster than that. Some of it slower. They're going to have to stop and rest and re-chalk their hands. But that's what they're going to average. That's going to be their average speed. You want to watch the climbers attempt to break the record for climbing El Capitan. On the morning of the climb, you arrived late at 11:30. When you arrive, the climbers are exactly halfway to the top. So at 11:30, this is my 3,000-foot face. Whoops. That's my 3,000-foot face. That's ground level. That's 3,000. And when I arrive at 11:30 a.m., they're halfway up. What's half of 3,000? 3,000 divided by 2. These guys are at 1,500 feet. They're exactly halfway up. So sometime before I arrived in the morning, they were down here. We can figure out when they started, and we can figure out their rate on when they're going to finish. Let's take a look at number 4. Assuming they are climbing at their average rate needed, how many feet up the cliff will the climbers be in 2 more minutes? So in 2 more minutes, they were at 1,500 feet. And their rate is 20 feet per minute. So, in 2 minutes plus 20 times 2 is 40 more feet. So 1,500 plus 40, they are at 1,540 feet. Again, units matter. How far up would they be in a quarter of an hour? Well, how many minutes are in a quarter of an hour? 60 divided by 4, or 60 times a fourth. A quarter of an hour is 15 minutes. So how far up the face will they be in 15 minutes? Well, they were at 1,500 feet plus their rate, 20 feet per minute, for 15 minutes. 20 times 15 is 300 feet, plus the 1,500 they were already at. So they would be at 1,800 feet after 15 minutes of you being there. After 1 hour of you being there. So again, an hour is 60 minutes. We're going to use that same, they were at 1,500 feet, plus they go 20 feet per minute, and they're going for 60 minutes. $20 times 60 is 1,200. 1,500 and 1,200 is 2,700 feet. So they're getting pretty close to the top. Because again, it's a 3,000-foot cliff. And again, an hour before you arrived at 10:30, they would have been 27 feet lower, so they only would have been 300 feet up face at that time. In this problem, which quantity depends on the other? Their height. The height of their climb, or height in feet, depends on time in minutes. So my y-axis is going to be their height in feet, and my x-axis is going to be time in minutes. Identify and define the independent and dependent variables with their units of measure. Well, the independent is the one we get to choose. That's going to be the time. Time in minutes. Is the independent. Variable. That's the x variable, the horizontal on our graph. And height in feet is the dependent variable. That's going to be our y. That's our vertical. Write an equation for calculating the value of the dependent variable when the value of the independent variable is given. Okay, so this is going to be of the form again, y equals mx plus b. M is our rate. B is our initial value. For y when x is 0. So when we arrive to watch, they're already 1,500 feet up the hill, or up the face. So this is going to be 1,500. And our rate is how fast they climb. They're going up the face, so that's a positive, 20 per minute. And again, x is number of minutes. Y is height of climbers in feet. So my equation, their height is 20 feet per minute plus the 1,500 feet when I arrived. If I had arrived when they started, this would have been a proportional relation because this would have been 0. As it is, this is not going to be proportional because from when I arrived, they were already 1,500 feet up. This is going to be a straight line, but it's not going to pass through the origin. So I'm going to have you try to take the information that we've been working with and see if you can apply it to pages 32 through 36. In the introduction to this whole section, I did the talk-the-talk page with the advantages and disadvantages of a graph, an equation, a table or chart, or a sentence. So if you need to, you can go back and look at that for help or guidance. Again, if you answer slightly different, that's fine. And if you solve the problems a little differently than the way I solve them, that's fine. Just make sure you can reliably get to the right answer, and all will be good. So, good luck on this. And again, look for the next video for the answers to page 132 to 136. Good luck.